Good afternoon, young people. This is Mr. Williams, and I am going to talk to you today about how to solve problems in, in physics. There's a method that we use, and I want to go over it with you. So the very first thing that we do when solving a problem in physics is read the problem carefully. Reading problems in physics is different than reading a story in English or reading a magazine. So when you read a magazine or you read a story, you can read really, really quickly and really probably understand pretty much everything that's going on without having to slow down. It takes a different skill to read in science and in physics specifically. You have to learn to read very, very slowly and look for all the hidden clues that are in the writing. If a story says a lady turns on her car and accelerates at 3.8 meters per second, if that's what the problem says, implied in that statement is the idea that she started from rest. So her initial position was 0, her initial time was 0, her initial velocity was 0. That's not stated in the problem, but it's implied, and you have to make explicit all of those implications. You have to read very carefully. The second thing that you need to do when solving a physics problem is draw a picture. This picture does not have to have artistic merit. It simply needs to show the important features of the motion and other things that may go on that are important from a physics perspective. Since we're just working on kinematics right now, motion is all you need to worry about. But as we learn more things, we may learn about more things later, you'll have to draw other things in your pictures. When working in kinematics, you need to draw in to your picture each of the 5 kinematic variables. And those are x, vf, vi, t, a, write the value of each variable. And if you don't know the value, put a question mark. Circle the variable or variables you must solve for. Write down your kinematic equations. Those equations are and figure out a way to get what you must solve for given the values you know. So I will do an example. In the night book, number 36, chapter 2. So chapter 2, motion in one dimension. Number 36, chameleons catch insects with their tongues, which they can rapidly extend to great lengths. In a typical strike, the chameleon's tongue accelerates at a remarkable 250 meters per second squared for 20 milliseconds, then travels at a constant speed for another 30 milliseconds. During this total time of 50 milliseconds, 1/20th of a second, how far does the tongue reach? Let's draw our picture. So here's my chameleon. Oh Lord, okay, yeah. That's my chameleon. I think they have tails. Right. Okay, and his tongue is all curled up. So here's his tongue inside of his mouth. That's my chameleon's tongue. So this is initial. And then my chameleon, like, let's see, what does he do? It says he accelerates for 20 milliseconds, then travels at a constant speed for another 30 milliseconds. So there's two parts to the chameleon's tongue's motion. There's the bit where his tongue accelerates. So I'm gonna. This will be. Let's actually not call it initial. Let's call it acceleration. There's a bit where his tongue accelerates, so it's speeding up. So it's like this. So during this acceleration time, let's write down our phi. By the way, I'm going to divide it into two bits: acceleration and constant velocity. That's something I didn't put on my list, but you should know that you basically treat every separate type of motion as a separate problem. So you draw a new picture for every different type of motion. When the chameleon's tongue is accelerating, that gets its own picture. When the tongue is moving at a constant velocity, that gets a separate picture. So then here would be my chameleon. And now his tongue is like this, but now it's moving at a constant speed here. Well, actually, this should be just exactly like this, because it's one continuous motion. His tongue is unfurling the whole time. These two things happen at the exact same time. This is just while his tongue is speeding up, and then this will be his tongue going at a constant speed. So now it's fully out, and I guess we should put little flies in here because he's trying to catch the fly with wings. And then and now he's caught the fly. So the fly is not very happy right now. Okay, here, what is my initial velocity? It says that the chameleons catch the insects with their tongue and they are, well, if his tongue's in his mouth, what's his initial velocity? It's going to be 0 because his tongue is not moving. Did the problem tell me what his maximum speed was? What is, no. It says it accelerates for 250 meters per second squared for 20 milliseconds. So I know the time here. The time up here is 20 milliseconds. 1, 2, 0.02. The acceleration is 250 meters per second squared. VF, I do not know. And I also do not know the distance. I need to know the distance because that's what the problem told me to find. So I'm going to circle it. Then here, I do not know the final velocity. I'm sorry, the initial velocity. I don't know the initial velocity here, but I do know that the initial velocity in this section is the same as the final velocity in this section. So if I find this, I'll have this. But I also know that the speed here is constant. So whatever my velocity is here, that's equal to VI is equal to VF. They're equal to each other because it says that the chameleon's tongue then moves at a constant velocity. That if it's a constant velocity, that means the acceleration is 0. You see I'm inferring that. And the time is 30 milliseconds, so the time is 0.03 seconds. And I also don't know the distance. So I need to know the distance here. I have too many unknown variables here. I am going to need to figure out this velocity here as well. So I've got to figure this out so that I can figure these out. I'm sorry, I need to figure this out so I can figure this out, which will give me this. That's my game plan. I'm going to write my equations out for the acceleration section. I need to find the distance. Well, the distance is not in here. I need to find the distance. Well, the distance is in both of these. I don't know VF. I don't know VF, and I also don't know distance, so this is not appropriate. So we're going to rely on this one. My initial velocity is 0, so this term becomes 0. My acceleration is 200. I really despise this Ladybug with every part of my being. It does not tell me with little lights where it's shining. This is just the most unwieldy thing. So 250 meters per second squared times the time of 0.02 seconds squared. .05 meters. All right, so that's how far his tongue went. I'm going to call this 1 and this 2. So this will be 1, this will be 1, 1, 1, to keep them all separate since the pictures are so close together. And this will be 2, 2, 2, 2. Okay. I found that. Good. Done. You'd find this. Well, looking back up at the equations I got rid of, this has VF in it, and this has VF in it. I can do either one. I'm going to choose this one because it's nice and simple. So A is equal to VF minus VI over T. If you rearrange it using algebra, you're going to get, looking for VF, VF is equal to VI plus AT, which is VI is 0. So A times T, which is 250 meters per second squared, times 0.02 seconds. So the final velocity here is 5 meters per second. So now that I know that this is 5 meters per second, and this was a constant speed, so this is 5 meters per second. All right, we're doing good now. All we got to find is distance. There's no acceleration. My favorite equation. I have no acceleration, so this becomes 0. And my equation becomes distance equals rate times time. That's the equation when you have no acceleration. And the rate is 5 meters per second. And the time is 0.15 meters. So the total distance is going to be distance 1 plus distance 2, which is 0.05 meters plus 0.15 meters, which is 0.2 meters. Boy, those things have long tongues for as small as they are. Its whole mouth must be tongue. Yeah, that's 20 centimeters. Holy mackerel. Is that right? I'm going to grab a ruler. Centimeters. That's that long. A chameleon's tongue goes out 20 centimeters. That's astonishing, man. It's astonishing. Okay, so this is the process. I have tried to write down for you how you solve it, and I've just shown you how to solve the problem using my process. That's what you do. Good luck. Have a good evening.